head of applied and scientific knowledge management and systems medicine projects at Biomax Informatics. Our main focus is on bioinformatics and knowledge management for the life sciences, industrial as well as scientific. So our role in AirPROM is providing the integration and the flow of information between all the partners that are participating in the project and making this kind of information available and ensuring that it's flowing easily so they can use it and analyze it, and we're bringing it together. Well, knowledge management is actually something every one of us, you are doing every day. If you read a newspaper, you capture information and you integrate information from different articles. And if after the weather forecast and the sports news, you call your friends and you arrange a picnic, then you're using that knowledge and you're sharing it with your friends. So that's knowledge management, basically. However, of course, in the life science and medical science nowadays, we have so much information that we need computational systems to organize this kind of knowledge. Yes, there are. AirPROM is a research project and there are challenges, both technical but also sociological challenges. So technically, the life sciences have had a huge development over recent years. We have a lot of different data types that are generated nowadays. We have, for example, an image of a lung. We have blood laboratory measurements. We have the whole genome of a patient. And we have computational models that try to describe what a diseased lung is looking like. And we need to bring these different types together, and these types are developing quite quickly. They're changing over time, and they have different meanings to different people. So in AirPROM, we have an interdisciplinary team of clinicians, of engineers, of biologists, and they use the same language, English usually, but they use different meanings for the same words. So the word model to a clinician might be a mouse, and they might be using the mouse as a model for the disease and testing different treatments. For the mathematician, the model is a mathematical description, while for the engineer it might be a three-dimensional physical model that they can try different things on. And that's another challenge that we need to capture technologically. Social, the life scientists are not yet used to using formal descriptions of knowledge. In physics, there has been developing over the last 100 years, and we now have a very complex description of physics. But in the life science, we're just starting to do that. And that's unusual. So that's something that people need to get used to. So the way we are attacking knowledge management is starting with a very intuitive understanding, with a kind of representation that everyone is using, and that's very object-oriented. So we are thinking about maybe an organ like the lung, and then another object like, say, the nervous system, and how that's influencing the lung. And that's what we managed to put into a computational system. And that allows us to react very dynamically on changes that are occurring in the life science. And in AirPROM, one important aspect is that a few years ago, no one thought about integrating knowledge about computational models and the data that's created in the clinic. And that's something we managed to do in AirPROM, and I think that's a very special thing. In these very interdisciplinary projects, we need to enable the partners to talk to each other, to find similar meanings. And that's something knowledge management is enabling. And a very extreme example is, you might remember a few years ago, a US satellite crashed because different teams were using imperial units and metric units. Now that's different meanings, and that's something good knowledge management can help you to avoid.